Welcome. In this video I'm going to show you how you can perform a post-hoc analysis for a goodness-of-fit test using pairwise goodness-of-fit tests with Python. I'm running actually Python version 3.12 and this video will focus on how to obtain the results, not so much on how to read all the results. To show you how this can be done, I'll load some example data. So therefore I first load pandas, so I can use their read CSV function to load the general social survey from 2012 adjusted for some example purposes. I don't need all their data, I just need one nominal field, so I'm using the marital status, which was written as mar1. Store that under nominal field, and just to give you a quick impression, 79 people selected that they were separated. I have a separate video where I show you how to can use my function, but just to have a quick preview, once you installed and imported my library, you just have a function there that can actually get you all the output that you need in one go. But as promised in this video, I won't be using that. So I first convert that nominal field, which is actually a panda series, now to a list. Remove any missing values by using the not a number. And I want to see all the different categories. So if I use a set, it actually removes any duplicate values from the data, which should be all the categories. Convert that back to a list and then show the results. So these are the 5 categories. Next, I want to see the counts. So I simply count for each of those categories, and that gives me that there were indeed 79 was that separated. So as you can see, 79 and separated are indeed the last one, so it kept the order hopefully. The number of categories and then the number of pairs, which is this little function or formula over here. And then we can actually set each expected count. So if we don't have them provided, we can simply actually use this. We sum up all the frequencies divided by the number of categories and then multiply that. With k, so that we have it for each category. In this case, I'm going to be using some predefined expected counts for each category. I think the order has actually changed, but it doesn't really matter, so let's just keep it like this. And then I need to actually adjust them also for each pair. So for each pair, I just calculate the sample size of the pair. So the expected proportion is simply the expected count divided by the sample size. And then the adjusted expected proportion will be the expected proportion divided over the sum of the two. So that's what's being done here, and that shows us for every possible combination that we now have, the original expected proportion and the adjusted one for each. Sorry, it's showing the one for each of the two categories. So these two should always add up to 1. Then we can actually select every possible data. So for each pair, we just select only those two. And then you can actually store that under one large list. So now you actually have all the data. So for example, let's add one additional cell. And let's say data of the first pair. So that would be 0. Then I have actually a long list. Actually, this was the last one. It's married and separated, so it just creates one long list with married and separated. So inside the loop itself, you get actually the data pair. So after this, you probably want to do, using this data pair, the test. So here, you want to write code for test the goodness-of-fit test on the data pair. And then you can do that for every possible combination. Now, I'm not going to go over all of the possible ways to do that because there are quite a lot of different tests that can be done. I have separate videos for each of those tests on how you could actually perform that test. Alright, I hope this was somewhat helpful and thank you for watching.